So let's review absolute extrema. How do you find the absolute greatest or absolute least value in a function on interval? So first of all, this is a table of values questions. We're going to set up a table of values, and we're going to start with the ends of the interval. We need to test those. Next, we're going to take the derivative. And then after I take the derivative, and again, if you need to, press pause so you can catch up. Make sure I did that right. Did I do that right? 6x squared minus 12x. Derivative 4, 0. Make it equal to 0. I'm going to factor and then solve. So I took the derivative equal to 0, factored, two answers, 0 and 2. I got to be careful. So 2 is not in my interval, but 0 is. And now I have my list of candidates, and whatever is my biggest y value is my maximum, the smallest y value is my minimum, and go from there. So I'm going to plug in -1, that's -2, -6, -8, plus 4, I think it's -4. +1, 2 take away 6, -4, plus 4, that's 0. Plug in 0, and the answer is 4. And now look. So what is your absolute max? So my greatest y value I see there is 4. What's your absolute min? That's the y small. Just be careful you do the basic math right. Like, you understand the big part, but you're not taking your time to make sure we're doing all this work correctly, especially plugging in and what the answer is to make sure it matches. So that's the first half. The second half is the mean value theorem. So for the mean value theorem, we're really looking for where the instantaneous rate of change equals the average rate of change. And so this is the derivative, and this is y2 minus y1, and then x2 minus x1. This is the old-fashioned way of finding slope in algebra. So if you're given a function, and I'll do a pretty simple one here. The one on the quiz redo is pretty simple too. So if I give you a function, and I say, okay, on this interval, so let's say I say from 0 to 3, can you find the mean value theorem? First of all, is it continuous on this interval? Yes. Can you take the derivative? Well, let's see. I'm pretty sure the derivative is pretty good. So when I look at the derivative, can I also plug in any number from 0 to 3 here and get an answer? Nothing's undefined. So both are good. Then I need to do the AROC. So on the side, I need to know f at 3. So if I plug 3 in here, let's see, 3 squared is 9, 18, take away 36, -18 plus 3, I think it's -15. Try again, 3, 9, 18. I did it wrong. All right, let's try it, break it down. So if I bring in 3, 3 squared is 9 times 2 is 18. And then -4 times 3 is -12. So this is 21, take away 12, so I get 9. Let's try it right. All right. 0, that's a lot easier. So f at 0 is just 3. And so AROC then is, make sure you're subtracting y2 minus y1, and then these are your x's, which is 3 take away 0. And then make sure you're doing the work correct. And so the average rate of change is 2. So I come back here, take the derivative equal to the average rate of change, and then solve it. So we're going to add 4, divide by 4. That's a good answer. And then that's the C value that we're looking for, where the average rate of change equals the instantaneous rate of change. All right, Mr. G Math, good luck. Till next time.